Hello, I'm Philip Marris. I'm going to present the 2-for-1 rule to reduce your work in progress and your lead times. And I'm the CEO and founder of Marris Consulting based in Paris, France. We do a majority of our business in projects, in production and in supply chain. After a brief introduction, I'll go through it step by step, how we set it up, how we do it, how we stop it, and the next steps after applying this rule. And it's a strange thing that we discovered a few years ago, and it replies to some fairly important questions, which is how to reduce your lead times and how could you improve your due date performance. Now, why do this? Well, nearly everybody needs to go faster, and that problem will never go away. You'll have to be even faster in 10 years' time, won't you? And it's the same with projects. You'd like to be able to do them faster, finish them sooner. And this 2-for-1 rule is just a very simple way of doing that. And it works both in production environments and in project portfolios. So what is it based on? Well, it's based on the idea, if we take the production environment, that you have too much work in progress in your factories. Okay. Now, you need work in progress to protect yourself against variability and uncertainty, of course, such as machine breakdowns, quality problems, absenteeism, and other things. Okay. But I believe that another reason, a major reason for having that much work in progress, is to keep everybody busy, to keep high OEEs on all the different equipment, and give the impression of everybody working all the time, right? But as a result, we find that companies have too much work in progress in the factory floor. Okay. In the project environment, in project portfolios, it's the same thing. And companies usually have too many projects simultaneously running in their portfolios, especially if they're free to start them themselves, right? If your projects are launched by a client order, then that might stay reasonable in quantity. But if it's stuff that you can decide to launch yourself, such as new products and other improvement ideas, you will end up probably with too many projects. And when you have so many projects, what happens? Well, the queues get longer everywhere, so your average lead time for your portfolio just gets longer and longer. And of course, you start multitasking between your different projects, and that reduces your efficiency, it reduces your quality, and it means that you finish fewer and fewer projects every year. So the underlying hypothesis of the 2-for-1 rule is you have maybe 2 times, maybe 4 times too much inventory in your system. Okay. Let's take this example. It's an engineering to order and make to order firm of about 400 people making big gearboxes. You can see the size of them by the person. Next to that gearbox, it's the size of a big bus, right? Expensive gearboxes that go between, for instance, a gas turbine and an electric generator and power station, that sort of stuff. Okay. They implemented the 2-for-1 rule and critical chain project management simultaneously, but initially it was the 2-for-1 rule that really brought in the results. Okay. The bottleneck was in their design office, so they applied it there. And they reduced their work in progress very significantly, and this had a very significant impact on productivity, since you can see that before they were producing 1.8 designs per week, and afterwards they were producing 4.2 a week, the same people doing the same job, right? Simply because this in that environment had significantly reduced the multitasking between different projects. The idea of this solution came from a factory in the middle of nowhere in France. We were helping a company that made pipes, and it was one of these factories, and there are many, where there was so much work in progress you couldn't see the machines anymore, right? There were piles of inventory everywhere, and you really had to spot the machines hiding between the big piles of pipes, in fact. Okay. And we were trying to reduce the lead times and improve due date performance. We talked about it. We taught various ways of doing this, but it wasn't working. And so we We're looking for something very simple and easy to implement. Okay, and that's where we came up with the 2-for-1 rule. Okay, the logic behind it is very simple. Lead times are directly correlated on average to your work in progress, right? The more work in progress you have, the longer the queues are, therefore the longer the lead times are. Okay, so if we want to reduce lead times, we need to reduce the work in progress. To reduce the work in progress, the stuff that's in the factory, we must ensure that more things exit the system, go out of the factory, than stuff that go into the factory, or especially the shop floor, right? There must be more stuff leaving the system than what is coming in. That's the only way of reducing what's inside. Okay, and so we came up with the 2-for-1 rule, right? You are not allowed to launch a new thing into the factory until you have finished 2 things. It was as simple as that. Okay, and that's the 2-for-1 rule. So I'm going to try and explain how we use it. I'm going to give a few examples in this presentation, but given the time in it, I won't be able to go into the details of any of these. Okay, so when do we use it? Usually right at the beginning, right? Because quite often these days companies are suffering more from having excessive lead times than they are from elements of throughput, and therefore when we start, often the question is, can we reduce our lead times? Can we improve our due date performance? Again, this is what the 2-for-1 rule does. And so if it is a theory of constraints implementation, we will in parallel do the 2-for-1 rule and the 5 focusing steps, or at least the first 2 steps of the 5 focusing steps. We will find the bottleneck and we will exploit it, use it better to get more out of it. Okay. But if that's not the point in the case, and we start more traditionally just with the 5 focusing steps, we identify the constraint and then we exploit it. You then come to step 3, and step 3 is subordinate everything else to the above constraint, and that means that you shouldn't launch into the system more than what the constraint needs, right? But if there's a huge quantity of work in progress before the bottleneck, you can't actually turn on the proper rules of subordination immediately, right? You need some kind of transition system, and that's when we use the 2-for-1 rule, right? To get the inventory sufficiently low to then be able to go properly into the subordinate step and do things like the drum buffer rope. Okay. So because as I say, if you have too much inventory and you just apply the subordination rule, in fact the system will calculate that there's too much stuff in the factory, and therefore you should launch nothing until the mess is cleared up. But if you do that, you're going to have problems, right? You have to be able to continue launching a few work orders into the system for a number of reasons. One of them is because you're going to have to catch up with operational problems, such as scrap rates and stuff, where you have to redo a batch because you've had high scrap rates. And in our experience anyway, we find that there are often forgotten work orders that have to be launched. Of course, they haven't been forgotten really, the computer hasn't forgotten them. It's just that the system was badly set up, and suddenly you realize that you need to launch a work order of that particular product, because otherwise you're going to run out. And the other reason for which it is useful to try to keep launching work into the system is if you don't, all the first operations, all the resources, all the people working in the initial operations in the flow will just have zero work, right? Which is going to be a very traumatizing experience. Okay, so before you can properly choke the release, as is often said in the theory of constraints literature, you need a transition system, and that is what the 2-for-1 rule is also. Okay, so how does it work? How do you set it up? Well, the first thing you have to do is decide what unit you're going to use for this rule. Okay, and most of the time in production we use work orders, and in projects we just use projects. And in a portfolio we use projects, the number of projects. Okay, but you can use other units. We have from time to time. You can use the number of parts. You can use the number of containers or pallets in the factory. You could use liters, you could use other stuff, but anyway, in the examples today we're going to use the work order and the project as the unit. You have to decide how violently you want to use this rule, okay? And I believe the best way of deciding that is to decide how many months you want to divide your lead times by 2. Right? I said you've got twice as much or 4 times too much work in progress and lead times. How can you divide it by 2? How quickly would you like to divide it by 2? Okay. And in production environments, we find people usually answer sort of 2 or 3 months, if possible, please. In project environments, they say, you know, I would like it immediately, but it takes a certain while because of inertia. Okay. To understand this inertia, let's look at 2 different examples. Production example. Imagine you have 4 months lead times initially. You apply the 2-for-1 rule, and you run it for 4 months. Okay. As a result, 4 months of work will exit the shop floor, and 2 months of work, half of 4, right, will be launched into the shop floor. Okay. So at the end, you'll have 2 months of work in progress where you had 4 initially, and so you'll have divided by 2 the work in progress and the lead times in 4 months. Okay. If we take a project portfolio environment in which we imagine that, for instance, the lead times are on average 2 years. Okay. If we apply this rule for 1 whole year, okay, if we apply this rule for 2 years, then 2 years of work will come out of the system, and we'll have only launched half of that 1 year into the system. So you'll only have 1 year's work in progress afterwards, and therefore you will have divided by your lead time by 2, but it will have taken you 2 years to do so. Okay. So as you can see in the project portfolio environment, if your projects take a long time, there's quite a lot of inertia in there. So even with a violent rule such as 2-for-1, it's going to take time to clean up. Okay. So just beware that if you're not careful, it can be a little too violent, especially in the production environment. Okay. Imagine you had a 1 month lead time, and you applied the rule. Well, at the end of 1 month, 1 month of work would have gone out, 2 weeks would have come in, and therefore you would have had lead times shrunk to 2 weeks divided by 2 in only 1 month. Now that's probably for most people rather too violent, so you might want to calm that down. Okay. What I'm trying to say is that although we call this the 2-for-1 rule, and it's a catchy name, the idea behind it is really to start less than you finish. There must be more stuff going out than coming in, and that will reduce the quantity that you have inside. Okay. So you've got to decide the speed at which you're going to do it. There is the 2-for-1 rule, that's the name. But if that's too violent, you can try variants such as 4-for-3. Let's say you finish 4 things and you only allow 3 launches, or even 10-for-9. That's to say, for 10 units going out, you just launch 9 units in. That's going to be a much smoother, slower improvement, but it will work just the same. Okay. Just to keep things simple, today we're only going to use the 2-for-1 rule throughout. So, how do we do it? Well, you've decided what the rule is, 2-for-1, and off you go. First thing to do, of course, is to explain it to everybody, because it's fairly traumatizing. Imagine all those people, especially those that are at the beginning of the flow, they're suddenly going to get half as much work as they used to, right? And they're going to not understand what's going on. Okay. But so you need to explain that with stand-up meetings and so forth. And you also need to, of course, explain to the rest of the organization, human resources, purchasing that might be disturbed by seeing a reduced consumption by the factory of certain things, sales and administration. Why sales and administration? Because probably you might not want to tell your clients you're doing this, especially if you're delivering late. If you have an on-time delivery performance problem, you might not want to tell your clients you're actually going to start not launching their work. Then, as you run it, you have a daily or weekly routine. It's basically linked to your MRP calculation, right, which are often done weekly, for instance. Okay. So you run the material requirements planning calculation, and it will generate suggested work orders to be released. Okay. But the rule says you can't release all of them, right? You can only release probably half of them, depending on how many work orders were finished in the previous period, the previous week, for instance. Okay? So the schedulers will then have to analyze all the different work orders that are proposed by the system and decide which ones seem the most important, the most urgent, and only launch those, right? Only launch the half they can. And the other half they just put aside and keep it. Okay? And you repeat this week after week after week. Okay? Now, several things happen when you start this. Okay? You're going to be forced to better understand what your computer is doing. Okay? And I'm afraid that in my experience this is rather fascinating and quite frightening sometimes, because the schedulers will look at this proposed work order and they will understand why the computer did that. You know, why does the computer want me to launch this particular work order for that product A when I already have 4 batches at various stages in my production? I don't actually need that. It's certainly not urgent. Okay? Or I look at this other batch, this other work order, and I see that it's planning to launch 1,000 units of product B, and I think, well, that's kind of excessive, because that currently represents 4 years of demand. Okay, so you're actually going to look in quite a lot of detail at all the proposals made by your computer, and you're going to have some big surprises probably. Okay, so as you do this, you're going to end up cleaning up your system and all the different parameters that control the dates at which you launch things and the quantities in which you launch things. Okay, so you'll be spotting mistakes in your routings. You'll be tempted to reduce some batch sizes, to reduce some levels of target inventory here and there, and also clean up your bill of materials. Okay, so all this will go on as you study the proposals done by the computer about what you should be launching. Okay. If you want the schedulers to be able to spend quite a lot of time doing that, cleaning up the data, okay, it would be best if you could try and reduce the quantity of firefighting that's going on in the factory, you know, changing the priorities of orders everywhere, so that the scheduler has to go and find it and reschedule it and hunt things down all over the place. So, if possible, it's not you can survive without it. If possible, it would be good to try and stabilize your priority system. And what we recommend is just very simple, born from experience. Try and ensure that there is only one list of priorities. Okay, one public list of priorities, and it's the only one. And get rid of all the other ones. We regularly audit organizations and find that there are, for instance, 4 or even 6 different lists with priorities, right? The production priorities, the sales priorities, the boss's priorities, etc., etc., etc. Try and get down to one list so that people waste less time arguing about which order is the most urgent. Okay. Also, when you do this, you're going to get the people at the beginning of the system only loaded 50% of the time, right? So 4 hours out of 8, for instance. Ideally, what you want to do, therefore, is to move these people down the flow to the last operations, okay, so they can contribute to producing more, getting more out the door, okay. And so you really should take this opportunity to train people and increase their levels of multi-skills. We had lots of nice stories like this one here. This is these are the people who invented ball bearings, and we implemented it in their system. And as a result, all the machine operators, mostly men, had to go down to the flow to the bottleneck, which turned out to be quality control, in which there were essentially women, sometimes their wives, and they started helping with the quality control, and that led to lots of interesting improvements, because they realized that how often they scratched the bearings when they were machining them and transferring them from one machine to another and stuff, and so it was good, and it significantly increased the throughput, of course, what was going out the door. Now, we recommend that you do the first 2 steps of the theory of constraints, but it's not an obligation. Okay, but if you do that, you do end up increasing the output, the throughput of the factory by 20, 50, or even 100%. Okay, You'll see in some of our videos we did one strange case in for the leader in the luxury goods business, where in their new product development portfolio we found and dealt with the first and the second bottleneck, and that enabled us to more than double the output of the system in just a couple of months. Okay, so this is just basic theory constraint stuff, right? Step 1, step 2. Here is an example from Safran Electronics and Defence, and it shows you how they went from 50,000 parts down to 12,000 parts over a year. Okay, and I just want to put this here because to show you that there is the rule, but then of course you don't just apply that rule while it's running, while inventory is going down. You can launch a lot of improvement projects here. Okay, and so there you see a list of what they did simultaneously as the factory was emptying to improve performance, right? Reducing setup times and moving machines around and improving quality and all these sorts of things. So the results there were impressive, since the lead times went from 9 months to 2.7 months in 1 year. They increased the throughput and the productivity of the whole of the 400-person factory by 30% in 2 weeks, and their on-time delivery performance, which was in fact the reason why we started all this, went from less than 50% to over 95%. Okay. Let's have a look at a quick video of the client talking about his experience of applying the 2-for-1 rule.
Au tout début, en septembre 2014, il y avait une autre règle qui a été mise en œuvre qui s'appelait le 2 pour 1. Alors, j'aimerais avoir ta réaction par rapport à ça, parce que c'était effectivement probablement une des choses les plus troublantes, en tout cas pour certains. Je rappelle, l'usine était en retard, et pourtant la règle 2 pour 1 qui a été mise en œuvre est de dire que nous devons attendre d'avoir terminé 2 produits avant d'en lancer un nouveau dans le système. Bref, on va retenir, arrêter de lancer. Donc vous êtes en retard, et il y a un consultant anglais avec un truc de théorie de je ne sais quoi qui vient vous dire vous êtes en retard, arrêtez de lancer.
Alors effectivement, quand on a lancé le 2 pour 1, effectivement, ça peut paraître bizarre puisqu'on a du retard et en même temps on dit on freine les lancements. Juste pour faire un peu de rappel, ce qu'on faisait donc avant la mise en place et le lancement du projet et de la théorie des contraintes, SAP nous disait de lancer, on réfléchissait pas plus que ça, on lançait. Ce qui fait qu'on avait une pile d'OF à pouvoir à mettre dans l'atelier, sans pour autant savoir lesquelles des pièces il fallait prendre. Ce qu'on a pris dans la théorie des contraintes, c'est plus tôt ou tard, plus tard on part, plus tôt on arrive. Et donc ça, c'est ce qu'on a eu en formation. Donc on a appliqué le principe du 2 pour 1. On l'a fait une première fois au début du projet, en septembre 2014. Ce qui a eu pour vocation de dire on ralentit, on ne lance pas, on laisse dans la machine. Est-ce que c'est bien l'homme qui décide de ce qu'il va faire et pas SAP, et donc l'informatique qui décide, donc c'est l'homme qui est aussi remis sur le devant de la scène. Et ça a été très vertueux puisque dans les premiers 4 mois, pour faire une première étape, de 52 000 pièces de l'encours on est passé à 20 000. Donc on avait déjà divisé par 2 en l'espace de 3-4 mois en appliquant la règle des 2 pour 1.
So, as you are applying the 2-for-1 rule, you're slowly accumulating a certain number of work orders that have not been released, right? Week by week, you continue, as I've said, sorting them and only launching half of them. So the pile of stuff that has not been launched will increase little by little. Okay. So what you want to do is about once a month, or another rule we use is when up to a quarter of your work orders are in fact blocked, not released, you want to try to explain to the computer what's going on. Okay, And what you do is you change the parameters that control the length of the lead times in the system, and reduce them. Okay. For instance, quite often, but not always, you identify wait times or between two different operations in a routing. Right. Please wait 3 days between each step in the routing. That sort of stuff. Well, you can reduce that, for instance, from 3 to 2 days, which would significantly shrink the planned lead times. Okay, and that's fine, because in fact, when you're doing that, you're telling the computer what has already happened on the shop floor, right? You're using the 2-for-1 rule. There's less and less inventory on the shop floor, so your lead times are going down, right? And from time to time, you tell the computer what's going on. That reduces the lead times in his system, and so when he redoes the MRP calculation, it says, "Oh, since you're going faster, that's okay. You didn't need to launch that," and so that's how you maintain the system regularly. You reduce the lead times as expressed in your computer system, but only after having actually changed the reality in the shop floor. Okay. As I say, this thing is very easy. We've been using it intensely during the pandemic, because obviously we couldn't be visiting our clients, so we had to change a little what we are doing with our clients and tried to do things that were simpler, that didn't need us to be physically present in their facilities. Okay, and the 2-for-1 rule has proved to be extremely effective, used by a lot of clients, many of which we haven't yet met. In fact, we've all done this online. Okay, and so often that process was simply just doing some online training, and then very light online assistance just to guide them down the path of the 2-for-1, and that's being used both in the production environment and in the project environment with equal success. Okay. So you're doing this, and an interesting question arises: when do you stop, right? Well, you do not stop when a foreman comes into your office and says, "Hey, you must launch some more work. I've got nothing on my machines." Right? That is not when you stop using the 2-for-1 rule, because, this being a theory of constraints conference, you all know that you should not keep all your non-bottlenecks busy all the time. Right? One of the rules of the theory of constraints, if I go back to its origins in 1986, is the level of utilization of a non-bottleneck is not determined by its own potential, but by some other constraint in the system. Okay, so it's not because non-bottlenecks start stopping and not having any work, right? No work in front of the machine, that you should stop the 2-for-1 rule. That is perfectly normal. And I remind you that non-bottlenecks are the vast majority of your resources, maybe 90% of your machines, right? So if a if a non-bottleneck is starved of work, that is not a problem, on the contrary. Okay? So that's not when you stop it. When do you stop it? When the bottleneck risks being starved of work. Okay? That is when you know that you might be reaching a dangerous limit, and you might want to then stop the 2-for-1 rule, because, again, quoting from these 1986 rules, an hour lost at a bottleneck is an hour lost for the whole system. Okay, so if you stop it, what do you do next? Okay, well, you can either just stabilize the system with its new level of inventory. Okay, for instance, with a CONWIP system, constant work in progress system, which is basically a 1-for-1 rule, isn't it? As to say that I only allow myself to launch one new thing into the factory when one thing has come out. Right? That means I maintain the inventory at a given level. Or you can implement the theory of constraints flow control solutions, such as in production, the drum buffer rope or the simplified drum buffer rope. Okay, and once you've done that, you of course implement buffer penetration analysis, which allows you then to decide what improvement actions should be launched and improve the system, and this allows you to further reduce the size of your buffers and therefore the quantity of work in progress and your lead times further and further, right? But then it's a continuous process of ongoing improvement. So, to conclude, all you need is a little courage to start all this. Okay? So, bon courage. If you do implement these ideas, I'd be very interested in hearing back from you, and I'd be delighted to listen to your stories and your experiences, and maybe new ideas and improvements to this 2-for-1 rule. Okay? So, that's me. Thank you very much.